Meticulous Mathematician's 11.5 Geometric Series video. A geometric series is an expression for the sum of the terms in a geometric sequence. You can use a formula to evaluate a finite geometric series. The formula is right here at the bottom. All you need to know for the formula is a sub 1, which is the first term, r, which is the common ratio, and n, which is the number of terms. So here we're going to evaluate the series. We know that r is equal to 1. R is equal to 3. That means that each term is increasing by a multiple of 3 each time. So for this example, we need to identify what a sub 1 is, which is 3, because that's the first term. R is a common ratio, and for this one, we're multiplying each term by 2. So 2, let's put a sub 1. Okay, we're going to pretend that that is a sub 1, and this here is going to be what r is equal to. To evaluate an infinite geometric series, we need to know that when the absolute value of r is less than 1, the series converges, meaning that it gets closer and closer to the sum, which is s. And when the absolute value of r is greater than 1, the series diverges, meaning that there's no limit and that there's no sum. This is the equation for the sum of an infinite geometric series. Here we use r again for the common ratio and a sub 1 for the first term, like we did in the previous equation. So for this example, we have to determine if the series has a sum, and if it converges, then we need to evaluate the series. If we go back to this slide, we know that when the absolute value of r is less than 1, it'll converge. So since here we can tell that r is equal to 1/4, that means that 1/4 is less than 1 and that the series will converge and get closer and closer to the sum. We ended up solving for the 6th term, and so this right here is the results of the 6th term.